Welcome to another segment of algebra. In my first video, I showed you how you can partition a line segment using the algebraic method. There's another method known as the graphing method or the graphical method of partitioning of a line segment. So let's look at that method. So for the same question, what are the coordinates of the points on the directed line segment from -6, -6 to 9, -1? That partitions the segment into a ratio of 2 to 3. So to use the graphing approach, we will first have to plot the points. All right, so let's plot the points. We have -6, -6. So let's plot that on the graph. So -6, x is -6, and then y is -6. So that takes us down here. So this is the point, -6, -6. Okay. Then other endpoint is 9 and -1. So x is 9, and then y is -1. So that is this point here, which is 9 and -1. Okay. So let's join the 2 points with a straight line. So I'm going to join this point here all the way to this point. Okay. So to partition this line into 2 to 3 ratio, so that means 2 to 3 ratio. First, we have to draw horizontal line between the two x values, right? So draw a horizontal line from that endpoint to the other x value right here. And then we're also going to draw a vertical line from the points, which is -1, all the way to -6. So we'll join the two y points. Okay, so the vertical line and then horizontal line. So it's like completing the triangle, okay, for this line segment. Okay. Now, once we've done that, we'll partition the horizontal line and a vertical line into the ratio 2 to 3. So first of all, we have to ask ourselves, what is the total number of parts that we have to break each line into? Total parts. So the total parts here will be 2 plus 3. We have 2 parts, 2, 3 parts. So it's 2 plus 3. So we end up with 5 parts. All right. Remember the ratio is 2 to 3. 2 to 3 ratio. That means 2 parts, 2, 3 parts. So it becomes a total of 5 parts in all. Okay. So we divide the horizontal line, that's the distance between the 2 points, the x points. We divide that into 5 parts. Okay. So how many parts do you have? What's the distance between 2 points? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have 15 divisions between the two x values. In other words, it's 9 minus -6, right? That's what we're doing. Remember, when we're doing the algebraic approach, we had a total, the distance between the x to be the absolute value of x2 minus x1. We did something like this, which is absolute of 15, which is 15 units. So there are 15 units apart. right? Which if you count here, you see that's 15 units. So we're going to divide this 15 units into 5 parts, right? Into 5 parts. So if we divide into 5 parts, that means that we have to break it down into 3 lengths of 3 units, right? Because 15 for each interval. So the interval that you want, the interval length that you want to was 15 over 5. So each one is 3 units long, right? So we divide 15 into 5 parts. So it's 1, 2, 3. So that is going to be here 1 part. 1, 2, 3, 2 parts. 1, 2, 3, 3 parts. 1, 2, 3. They have 4 parts. And then 1, 2, 3. So we divided the horizontal into 5 parts, right? Then we'll do the same thing to the distance between the 2 y points. So if you remember from the algebra approach, it's going to be y2, which now we have -1, minus your y1 here, which is -6. So we end up with absolute of 1 plus 6, which is 5, which gives us 5 units. So the length between the 2 y values, the total length here is 5. You can see 1, 2, 3, 4, 5. So 5 units. And using the graph, you can do everything on the graph. So we have to divide this length here, which is the 5 units, into how many parts? We want 5, we want 2 to 3, ratio of 2 to 3. So again, we're going to break it down into 5 parts. So if you take, so it means each length or interval length that you want will be 5 divided by the total number of parts. So each length is 1 unit. 1 unit, right? Each interval length, which you can easily see here. So you have 1, 2, 3, 4. So I divided this length here, vertical, into 5 parts. 1, 2, 3, 4, 5. So 5 parts horizontally, 5 parts vertically, all right? So since I want the ratio of 2 to 3, and the question says that the line is directed, you have a directed line segment from this point, -6, 6. So we're going to look at this endpoint, -6, 6, and select 2 parts from this, 2 to 3. So I'm going to take 2 portions or 2 parts from -6, -6. So that would be 1 part, 2 parts from the end. So that will take me to this point here. And then I'm going to take 2 parts along the vertical, as it's also from the -6 and negative. So this end here, right? It's start from this end here. So if I extrapolate, there's a point here. So we're going to 2 parts from the end. So take 2 parts, 1 part, 2 parts. So that takes us here. Okay. So once you've done that, then you're going to draw a line. So this is a point that you're interested in, this point and that point. Okay. So now draw a line, vertical line up, and then horizontal line from this point here. Okay. So wherever the 2 lines meet, that will be the point of partition, all right? So that's the point here. So this point here is -4, sorry, is 0, and -4. So that will be the point. X is 0, and Y is -4. So that's the point that we have here, right there. So that's a partition point. So your answer to the partition point will be let's call that P. And that will be 0, -4. All right, so pretty much very simple to use a graph to partition this line segment into 2:3 ratio. All right, so you have 2 parts here, and this is a 3 parts. Okay. Good. So I hope you find this quite easy and interesting. If you use a graphical method, you come out with the same answer. So this is my first video, and compare this to the algebra approach. Okay, great. Now let's try another question. So the question says, what are the coordinates of the points on the directed line segment from -6, -5 to 9, 1 that partitions the segment into 2:1 ratio? So since we want to do this graphically, let's plot the points. I also did the same problem algebraically. So check my first video how I did that. So let's plot the points since we are using a graphical approach. So we want to plot -6, -5. So x is -6, -5. So down 5 places down. So that'll be here. It's -6, -5. And then the other point is 9, 1. So let's go for 9, 1, 9 here and 1. So this 9, 1. Okay, let's join the point with a line. So I'm going to join this point with a straight line. Okay. So let's complete a triangle for this. So horizontal line between the two x values. Okay. So there's a line here. Then vertical line from this point, the first y value to the second y value, vertical down. So in other words, you want to find a distance between the x values and y values. So what's the distance between -6 and 9? We can count, or we can just do the distance between x, the change in x. So x2, -2, -6 minus 9, or we can do 9 minus -6. 9 minus -6, you can get the same answer. So that will be -15, opposite of that, which is 15. So 15 units, okay, 15 units. Distance between the 2 points. You can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. You get the same if you count. All right. Then find the distance between the y values. So 1, 2, 3, 4, 5, 6. Right. You have, yes, 1, 2, 3, 4, 5. 5. You have 5 units between the two values, or we can do -6 minus, sorry, it's -5, y is -5. So I have -5 here, minus 1. So that gives us absolute of -6, which is 6 units. All right. So let's check again. I think I counted it incorrectly here. So we have 1, 2, 3, 4, 5, 6. Okay, so 6 units separating the two numbers here. 6 boxes in between. All right, good. So now we want to partition each the horizontal line and the vertical line into the ratio of 2 to 1, 2 to 1. So how do I do that? 2 to 1. If I 2 to 1, that means that the total ratio here, or the total parts, the total parts this time will be 2 parts plus 1 part, which gives us 3 parts, right? 3 parts. So I have to break down the intervals into 3 parts. So let's do that. So about 15 between this X point, that means that each length, small length, will be 15 divided by 3. I have to divide to 3 parts, right? So it's like 15 divided by total part. So it means that each length or interval should be 5 units. So that's called the interval length. Five units for the X. So let's break down to 5 units. So 1, 2, 3, 4, 5. So that'll be the first division. 1, 2, 3, 4, 5. 2, so 1, 2, 3, 4, 5, right? So we divide into 3 parts. You have to divide the Y also into 3 parts. So what will be the interval length? How long should each piece be? So it's 6 units, breaking into 3 total parts. So that gives us what? 2. So each piece or each length has to be 2 units. So vertically, let's see. All this is 6. So break into 2 each. 1, 2. So 1, 1, 2, 2. So I have 3 parts here, 3 parts there, horizontally, vertically. Now I want to choose 2 parts from -6 and 6, because the question said directed line segment from this, so I want from the end. Okay, so let me choose 2 parts from that end. So I have 1 part, 2 parts, and this is the last piece. Do the same thing for the vertical distance. So I'm going to start from this end, for this is a point that I'm interested in, from this end of the line. So from this end, I go up 1 part and 2 parts, right? There's a 1 part left. So 2 parts to 1 part, 2 parts, 1 part. Once I do that, I can draw a horizontal line from this point, because this is a point that I'm interested in. Okay, that represents 2 to 1. So I draw a horizontal line. Let's use the green. Draw a vertical line up, touches the line, then draw a horizontal line to touch the line segment. Wherever the 2 lines touch, that will be the partition point. So these are partition points. So the point that we have here, let's label that. So this point that we have here is going to be 4 and -1. So our partition point. So the point that will partition this line into 2 to 1 ratio, let's call that P, will be 4, 1, 4, 1, right? So that will be the answer if you do the graphical method. Compare this to the graphic method. Compare this to the graphical method and realize we got to the same answer, right? So check that out video and compare the 2 methods. And they are pretty much easy to understand. Okay. I'll see you in my next video. I hope you enjoyed this one. Bye-bye.